Everyone, Shivank here. Today we'll be seeing the project that I've been working on for past couple of months, and we'll be looking at a small part of it. So, what today we'll explore an exciting part that involves extracting red marks from images, and by the end of this video, you'll have a clear understanding of how to process images for to filter out red marks. Let's get on with it. Uh, what we'll use first about my project. It was supposed to be a marks calculator system that will scan any PDF or image to detect red marks written in red ink, and it will use a model deep learning model to extract these marks. But for this tutorial, we'll be limiting to only filtering the uh, red marks from an image and exporting the image with the filtered red marks. So let's get started. What we'll use? We'll first use two libraries that will be working in Python. So be using two libraries in Python commonly used for the image detection and the handling of arrays. The first library is the OpenCV library, that is the open source computer vision library, which is a powerful library for image processing tasks. And then the other is the NumPy, which will only be using for you know processing an array or generating an array value. So let's get to it. First, let's import. If the libraries are not already installed in on your system, then you can use the pip install OpenCV Python. You can type this command into your terminal and hit enter. This will install the OpenCV library on your system. Let's first import CV2. This is the OpenCV library. Then let's import NumPy and we'll use it as NP. Since what we'll be doing in this tutorial is we'll be filtering out the red marks. So let's first define a function named as filter red marks. We'll be passing an image to this function. So now we come to the first thing, that is HSV. The images that we normally deal with are in the BGR format, the blue, green, red format, but the OpenCV library works better with the HSV format. What is the HSV format? This is a set of values of hue, saturation, and value. The hue determines the color type, the saturation, the intensity or purity, and the value determines the brightness of the color. Hue ranges between 0 to 18, one OpenCV. Okay, so first let's convert the image that we'll get from the function to an HSV image. Let's name this image that will be returned after the conversion as HSV image only. And then we'll use the OpenCV function convert color. We'll pass image to it and we'll use color. Since we are converting BGR to HSV. Okay. Now we have converted the image from BGR format to HSV format. Now we'll define two ranges for the red color. One will capture the lighter reds, and the one will capture the darker and more intensified reds. So let's define ranges for red in HSV format. Let's use the name as lower red 1, and we'll be using here the numpy library for just defining an array that will use np.array. This will convert the list passed into it into an array. uh, for red we have in the use we have two ranges for red, 0 to 10 and 170 to 180. First we'll take the 0 to 10 value, so u0, and we'll take the value of saturation as 70. and brightness will take as 50, let's see. Then we'll define upper red 1 equals to np dot array 0 to 10 we were gonna go, and 70 and 50 will declare the less, that is if the red is more faded or grayish, and 50 will define more or less bright ranges. Now to go full intensified and fully bright, let's define another range that will be the lower red 2 to upper red 2, np dot array. We had 0 to 10, now we are going to go for 170 to 180. 170, 70, comma 50 to upper red np dot array 180, comma 255, comma 25. Now we have defined the two ranges, and here you can see a saturation of 70 means the red color must be somewhat intense or vivid. 255 is the maximum saturation level, which will ensure that the red color can be as vivid as or intense as possible. 50 ensures the color is not too dark. Maximum brightness 255 ensures that it also includes bright reds. Okay. Now that we have the ranges, we'll now create a mask. A mask is to be created so that the red marks written in red ink will be. Let's create a mask. Let's since we have two ranges, so we'll have to create two masks. The first mask will be cv2 dot. We'll use the in range function. What the in range function does is that it highlights the pixels within a specific range that we have already defined before, and setting them to white, and the color that we have the range that we have defined, it'll set them to white, and all the other hues and the colors it'll set them to black. So this is the in range function. To this will pass the hsv image, and then we'll have the first set of lower red and upper red range, comma upper red. Let's copy this and just rename it to mask 2 hsv image lower red 2 to upper red 2. In this we have two masks. The first mask highlights the lighter red areas, and the second mask highlights the darker red areas, but we'll just combine both of these masks into one, and let's name it just as a red mask. We'll use the bitwise OR operation in the OpenCV library to combine both of these masks. Mask 1, comma mask 2. So the mask has now been created. Now we'll be using the mask to filter the red marks from the image. Okay. We'll give the since an image will be returned, a pixmap map image will be returned, so we'll just name it at red marks, and we'll use the cv2 bitwise AND operation. This operation keeps only the red areas of the image and sets all the other regions to black. For using the bitwise AND operation, we'll write it as, wait, I'll explain it to you. Mask equals to red mask. What this does is it uses the red mask that we created before, and it applies it on the image that we have, and then it saves it in the same image, so that now we have a converted image with a filtered red marks. But now we'll also convert this to gray scale. We'll have to convert it into grayscale because it makes it easier to extract contours for digit detection later, and it also makes it easier for the OpenCV library to handle it and other. We'll use the same function that we used before for the HSV image. We'll just write cv2 dot convert color. We'll pass the image, since we have now stored it in red marks, so we'll pass the red marks image, and then we'll write cv2 dot color, and we are converting BGR to gray. Now we've got a final image which which is in the grayscale format, and only the red marks are visible. Since we have created a function, we'll have to return something, so we'll return this final image. Now our function is finally created, but we also have to test it. So let's look at some of the images that I already have saved. Look here, let's take this. Let's take a much this one. This is an image of an exam copy from my college only, and see, there are a lot of red marks in it. The According to what we have already done, only these red marks should be visible in the final image. So let's use this. What you will do is you'll copy the path to the image. Now outside the function, we'll initialize a new variable as input path, and we'll use raw strings for it, and put the path, and now we'll put the name of the image, that is image 12 for me, image 12.jpg. This sets the image path. uh, but the OpenCV function does not identify the image, so we'll convert the image to a bitmap file. So we'll have image equals to cv2.imread, and we'll pass the input path as the argument. Now we'll call the filter redmarks function on the image. But since the function is returning an image, so we'll name the image as red filter image, and we'll catch it into it. Now we have the filtered image in this variable, but we'll not be able to see it because it's in the bitmage format. So let's export it. We'll export it using the same OpenCV library. We'll use cv2.imwrite, and here we'll first define the output path. Let's use the same path that we used before, and we'll output it as red marks filtered image tutorial dot jpg. let's and pass to it the red filter image. So this is a final function, final complete Python script for filtering the red marks from the image. This is the image that we have. It after filtering it, we should only be left with these filtered out red marks. So let's run the script. So the script ran successfully. Let's look for it in our folder. So it should have been here, but I can't find the image. So let's go back to our script. Maybe we made some mistake. Let's look for the warnings here. Yeah, we we have two packets here, both of the places. So it was giving the warning as a parameter missing, and also let's change it to PNG. So because normally the .png format is used. Okay, now it's done. Let's run it again and let's go to the folder. Yes. So first let's see the image. This is the original image, and now we'll open the filtered image. See, original image and the filtered image. Only the red marks have been filtered and everything else has been turned to black. And the line also got filtered because it was somewhat red, although it was supposed to be pink. But yeah, it also got filtered some. And that's how we extract red marks from an image. By carefully defining HSV ranges and applying masks, we can isolate specific colors with precision. Thank you for watching.